Today's lecture is going to start with probability. We're just doing this one section out of the probability chapter, just 12.1. And we're going to start by talking through theoretical probability and empirical probability. So what I have up here is just a coin. And this coin has, of course, two sides. So we're looking at heads right now, and if I flip it over, we're looking at tails. So if I flip this coin one time, and I'll just kind of do a little flip here on the thing. If I flip it one time, there, did it focus? This time it landed on tails. But I had two different ways it could have landed. So as I take a look at this, what I'm trying to come up with is a number that we can use to quantify the chance of something happening. So that's what the probability is. So the probability of some event is a number that describes the chance of it happening. That describes the chance of the event happening. Okay, so how, did I spell that right? How likely am I to get tails? Well, I have a 50-50 chance, right? A 50-50 chance or a 1 out of 2 chance. So if we go through some examples, so like I just did the toss the coin, so I'm going to toss the coin once. The probability of getting tails is 1 out of 2, or we can think of that as the equivalent percentage, 50%, or as a fraction, 1 out of 2 is 0.5. Well, what I've described quantitatively now with these numbers, with the 1, this is the number of favorable outcomes. There's only 1 tails on that coin. And 2 is the total number of outcomes. So this is the total number of outcomes. There were 2 possible. So we come up with that 1 out of 2. This type of probability, where we have favorable divided by total, is called theoretical probability. So what we're computing here is the theoretical probability. And again, to figure that out, the probability of some event is just the number of favorable outcomes over the total number of outcomes. Okay, so here's another example of a probability. Let's say that we looked up some national study, and we found that 30% of adult Americans, I should capitalize American. So 30% of adult Americans get 8 or more hours of sleep a night. So 8 or more hours of sleep each night. You go choose a random American adult, and we want to know what the probability is of that randomly chosen American getting 8 or more hours of sleep. So you're going to select an American adult at random. What is the probability that they get 8 or more hours of sleep at night? So the 8 or more hours is my favorable outcome, but I can't do favorable out of total. I can't say there's 1 outcome out of so many. So instead we're going to do an empirical probability. And with the empirical probability, we use known results, like a survey or a poll or some kind of a national percentage like we have here. So this 30% means in every 100 Americans, I'll find about 30 who get 8 or more hours of sleep a night. So I kind of do have a favorable out of total, but I have to get that out of the percentage. So my answer is, what's the probability? Well, there's a 30% chance. So I change this into my number. I change that just right into a probability. So 30%, or we can think of that as 0.3. Since we're using numbers from a survey, or a poll, or some kind of data, we call this empirical. So this is empirical probability. So we've got 2 different ways of computing probabilities. We're going to see some more examples of those. Let's go back to our coin toss. So back to the coin toss. I want to define a few things. So the event is the favorable outcome. So event, or E, this is the favorable outcome. In our example, we were going for tails. Then P of E is the probability that the event happens. And in our example, we did the probability of tails. Well, there's one tail out of two possible outcomes, so we got 1 out of 2. Another vocabulary word here is the sample space. The sample space is the set containing or of all possible outcomes. So now we're talking about that denominator. For our example, we did a coin. Our sample space would consist of the tails, which was on one side. So the tails on one side, but on the other side we had heads. So we have tails or heads, 2 possible outcomes. So that's the sample space. We can also talk about the number in the sample space. That looks familiar, right, from when we learned about sets. The number in the sample space is just the number in any set. So that's going to be 2. And the number in the sample space happens to go, so 2 for our example, goes right into the denominator. Okay, so now let's change things. We'll call that 1. Number 2, now let's toss 2 coins. I'm going to do the sample space first. And I'm going to do the sample space with what we call a tree diagram. With a tree diagram, I go ahead and write out my outcomes. Each row represents one of the coin tosses. So in the first coin toss, I could get either heads or tails. I'm going to leave some room because I'm going to branch off. In the second coin toss, after getting heads first, I could follow that with either getting heads or tails. Tails in the first coin toss could be followed by getting either heads or tails. Well, what I've done with these branches is to pair off my outcomes. So now I've got a sample space, and I can either read it off my tree diagram or I can write it out. I have heads followed by heads, so that would be HH. I have heads followed by tails. Order is important because look over here, I had tails on the first coin and then heads on the second. So tails followed by heads, and then finally tails followed by tails. Okay, so there's my sample space, either as a tree diagram or more specifically, I have it here as a set. I can talk about the number in my sample space, and I can see it here. 1, 2, 3, 4 possible outcomes. Those outcomes are a pair of heads and tails. Let's do a probability for this one, a couple of them. Okay, so what's the probability of getting both tails? Remember, I want favorable out of total. So to get both tails, there's only one favorable outcome. So I put 1 out of 1, 2, 3, 4 possible outcomes when I toss 2 coins. So 1 out of 4, or 0.25, or 25%. All of those are acceptable ways to represent your probability. What's the probability that I get at least one tail? One tail. At least one. That means 1 would be the smallest number of tails I'd accept. So really I would do 1 or 2 would work. So 1 or 2 tails. So now I'm going to run through my sample space and I'm going to look for how many favorable outcomes. This isn't one of them. But heads, tails, there's 1 tail. This one has 1 tail. That one has 2 tails. So that means I've got 1, 2, 3 favorable outcomes out of the 4. Or 0.75, 75%, however you choose to represent that one. If I were to do 3 coin tosses, I want to do another tree diagram. Oops, there goes my coin. So if I were to do 3 coins, I'm just going to build my sample space using a tree diagram for this one. Here comes the first coin. Leave some room. I can get either heads or tails. For the second coin, I can follow heads or tails with another heads or tails. For the third coin, I can follow each of these branches now with the heads or tails. So I can follow heads, heads with heads or tails, heads, tails with heads or tails. Same thing over here. Tails, heads could be followed with heads or tails, and then tails, tails can be followed with heads or tails. Now I could describe that sample space as a list inside a set. I'm not going to do the whole thing though because there's quite a few. So all heads, 2 heads and a tail, and so on. Let's do the number in the sample space. I could list all of them out, or I could just count up the branchings. So every end of a branch is one of my outcomes. So there's 1, 2, so I can just count the bottom row. 1, 2, 3, 4, 5, 6, 7, 8. So the number in my sample space is 8. So we can use tree diagrams. They're a really great way to look at sample space, which gives you that denominator. Okay, so here's another example. It's called a C. So we surveyed 500 college students. Within that survey, 327 said that they had student loans. Number 1, we want to know what the probability is that a person selected at random, a college student selected at random, has student loans. So it's kind of like favorable out of total, but we're not looking at outcomes. Instead, we're looking at data. So we're going to look at our survey. So 327 out of 500 becomes the probability. So I just changed that fraction of people with student loans from my survey into a probability. I'm just going to grab my calculator and do that division. 327 divided by 500 is 0.654, or 65.4%. Let's see, I gave you a number 1. Where there's a number 1, there's a number 2. So let's do number 2. What's the probability that this person selected at random does not have a student loan? So not have a student loan. Well, if 327 had a student loan, that means that the rest out of the 500 didn't have a loan. So my favorable outcomes are going to be the rest of those students. So 500 minus 327 is 173. So 173 of the students surveyed didn't have a student loan. I had 500 total. So if I do my division, 173 divided by 500, I get 0.346, or 34.6%. Do you notice something between these two percentages? Of those students that I'm selecting at random and asking, do you have a student loan or not, their answer is either yes or no. So they're going to fall into one of these two categories. Not both, just one of those two categories. So if you check, and if you add 65.4% to 34.6, you'll see that those two add up to be 100%. D, let's look at odds. So instead of trying to draw an urn, I'm going to draw you a box with balls in it. We're going to have yellow balls, 1, 2, 3, 4. We're going to have 2 orange balls, 1, 2. Hopefully this shows up in the video. If not, I will point them out to you. And then we'll do some green ones. Let's do 3 green. 1, 2, 3. So we have 2 orange, 3 green, and 4 yellow. So I'm going to go ahead and put some odds together for you. Number 1, odds are different. The odds in favor of, you can't see what's in here when you put your hand in the box and you randomly grab one out. So what's the odds in favor of drawing out a yellow? Well, first of all, with odds are win to lose. Well, I'm going to win if I get a yellow. So I count up my yellows. So I've got 1, 2, 3, 4. So it's 4, 2. I'm going to lose. I don't want the total on the other side. I just want the losing balls on the other side. Those are the green and the orange. 1, 2, 3 green plus 2 orange is going to be 5. So 4 yellow to 5 not yellow. So the odds in favor of yellow is 4 to 5. It's winning to losing. If I were to change this into a probability, so I'll call that part A, part B, and I wanted to know what the probability of getting a yellow is, well, now I'm going to do favorable out of total. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 balls total, so that would be 4 over 9. Notice that that denominator is the same as the sum of those two. This is kind of like the last example. You're going to either get a yellow ball or you're not going to get a yellow ball. We call this binomial. So that means that these two numbers added together equals the number in my sample space. So those two together equal 9. Let's do another odds. So number 2, let's do the odds in favor of orange. So remember, I'm doing win to lose. So how many oranges do I have? I will win if I get one of those 2 oranges. So there's 2 orange balls. The rest of them are not orange. So 1, 2, 3, 4, 5, 6, 7. So win to lose would be 2 out of 7. I'm going to call that part A. If I change that into part B and say what's the probability of getting an orange, that's going to be 2 out of, not out of 7. Remember, the 7 was just the non-orange balls, the losing balls. 2 out of the total. 2 plus 7 gives me all of them together, which is 9. So 2/9. Let me do another example without this box of balls. Number 3. Let's say that the odds given in favor of your team winning the World Series. Okay, so a lot of gambling or a lot of sports and things like that are given in terms of odds, is 7 to 4. Okay, that's good, right? Because 7 is winning, 4 is losing. So they have a 7 to 4 chance of winning. Well, this might make more sense to you in terms of a probability. So if I turn this into a probability that my team wins, I'm going to turn these odds, and there's a lot that go into these odds, and we're not going to go into that. That's why I started with a box of balls example. But that's what they figure, 7 to 4 winning to losing. So to change this into a probability, I need to go 7 divided by 7 plus 4. That will give me that denominator. So I get 7 out of 11. So let's see, what is 7 out of 11 on my calculator? That's about 0.64. So about 0.64 or 64%. Not bad odds, but not great. There's still a pretty good chance that they could lose. Actually, what, a 36% chance, right, that they could lose. So those are the odds, and that's all we're going to cover out of probability. So just really want you to know the basics, how to set up a probability, how to do a sample space, how to figure out odds, and how to go from odds to a probability. So you need to know the difference between those two. The next part that we're going to cover are statistics and statistic displays of data. So in this next section, which is 13.1, we're going to look at statistics and displays of data. I'm just going to say and displays. This is 13.1. Well, I want to go over some vocabulary to start. So some vocab. We're going to be looking at a lot of things, such as a population versus a sample. Now we're going to be looking at data, so population versus sample. So if I was doing some kind of a study and I wanted to figure out what the average age of students was at Wenatchee Valley College, the population would be all of the students at the college. And if I based my study on the ages of the students in the classes that I was in, that would be my sample. So the classes I'm in, I'm just going to ask those students what their age is in. That would be my sample. And then I'd use that sample to make a prediction about my population. We have different types of data. So we have qualitative data. Qualitative data is something that describes a characteristic that's not numerical. So this might be like hair color, gender. Now, while I'm writing these down, if you were doing some kind of computer program, you could assign these to numbers. But really, it's qualitative because it's a quality. So hair color, gender, let's see, what else would be a quality? We could also say something like what your, oh, there's so many things. Why can't I think of something? What your favorite color is. Something like your student ID number, your 905 number. You could think of this one as qualitative too because it describes you, it identifies you. But if we were using that 905 number as some way to say that you registered before somebody else, then it would be quantitative. So a lot of these cross over. Quantitative data, these are numerical, quantity. That's how you will remember. So these are numbers. So hair color wouldn't be a number, but my age would be a number. So age, height, salary, etc. So qualitative could be a number, but it's something where the number isn't meaningful. It doesn't mean you're better than somebody or ahead of somebody else. It's just maybe a number that identifies. But for the most part, things that aren't numerical, like hair color, your gender, your favorite color, things like that. With these different types of data, we will be assigning variables. A variable is a little different than it is in algebra. A variable is something that identifies some kind of a characteristic, and it could be a quantitative characteristic or a qualitative characteristic. In my next example here, the variable that I'm going to assign will be age. And it's a variable because the age is going to take on lots of different values based on who I'm asking. Let's see. Oh, and then one more piece for this list, and that's a distribution. A distribution in statistics is just a list of data. But instead of calling it a list or a collection of data, we call it a distribution. So all of these things together help us do statistics. When we're doing statistics, we are analyzing data, and we're analyzing data to make inferences, to draw conclusions, to make some kind of a prediction. So we use statistics to analyze and summarize data. Okay, so let's get to an example, B. So my example is going to be about age. So I'm going to let my variable x equal age. So I asked 10 people what their ages were. And these 10 people reported their age. Here comes my distribution as this. So 17, 23, 27, 23, 18, 19, 20, 21, 42, and 16. So there's my distribution of data. I'm going to put this data into a grouped, which means I'm just going to have categories or classes. A grouped frequency. Frequency means how many per group. Distribution. Do I have enough room? Distribution, which is just a list. So it's a categorized list. So across the top here, I've got x. That represents my variable. I'm going to show you the tally, which is super easy. The frequency, and the relative frequency. And I'm going to group my data this way. I'm going to do 15 to 19, age 15 to 19, 20 to 24. So in groups of 5, 25 to 29, 30 to 34, 35 to 39, and 40 to 44. That gets all of my data. So let me extend these just a little bit. Okay, and here I go. Where's my yellow pen? So I want to just tally how many I have in each of these categories. These are my classes. So we call those categories a class. 15 to 19. So I've got the 17, the 18, and the 19 and the 16. So I've got 4 there. So my tally is just this, 1, 2, 3, 4. And then the frequency, I write the number 4. I think the tally is kind of silly, but your book asks you for it, so I'll do it too. And now let's find 20 to 24. So the 223, so there's 1, 2, and the 20 and the 21, 3, 4. So I've got 1, 2, 3, 4. Again, there are 4. 25 to 29, it looks like there's one of those, the 27. There's nobody in the 30s, so nobody 30 to 34, nobody 35 to 39, so I put 0, 0. And then 40 to 44, I've got that last age of 42. So I have 1 here and 1 here. For the relative frequency, I need my number n. So n, just like it's been in the past, is the total. So n is equal to, let's add them up here, 4 plus 4 is 8, 9, 10. So that's just the total number of people. So that's 10. To get the relative frequency, I'm going to answer the question as 4 out of how many. So this is going to be 4 out of 10, or that would be 0.4 or 40% in the first class. In the second class, same story, 4 out of 10, which would be 40% or 0.4. And then I have 1 out of 10, so 1 over n. So 110 would be 10%. These are 0% for the 30s. And then finally, I've got another 1, so that would be relative to 10, 1 out of 10, which would be 10%. So that's the whole thing. That is my grouped, because I've got my classes, frequency, because I'm telling you how many there are per class, distribution, and distribution just means a list of data. Now we're going to look at some displays of data. The first display of data that we're going to see, and I'm going to go ahead and use my grouped frequency distribution. Or actually, let's back up here. Let's just use my list of ages. That might be easier. So we'll go back up here. So number 2, we're going to look at a stem and leaf plot. Stem and leaf. So for the stem and leaf plot, all of these numbers have a tens and a units spot. So along this edge here, I'm going to put the tens, and I have 1, 2, 3, and 4 for the teens, 20s, 30s, and 40s. And then along the other side, in order, I'm going to write the ones digit. So for the stem and leaf plot, these are the tens digit, and these are the ones digit. So really kind of cool, quick way to look at a distribution. Okay, so 16 was my smallest one, right? So I had 6, 7, 8, 9. So 6, 7, 8, and 9. For the 20s, what was the smallest? 20. So I do put the 0 in because that keeps track of that 20. And then 21. I had 2 23s, so I put the 23 twice. So I can read that as 20, 21, 23, and another 23. For the 30s, I had nothing. I don't write 0 because that would show that I had somebody at 30. So I leave it blank. And in the 40s, I have 42. And I'll bet I missed one, didn't I? So let's see, what did I miss? The 20s. So in the 20s, I had the 23, and then I also had the 27. So I missed that one, so the 27. So if you look at this, it kind of looks like a bar graph, right? So in the teens, I've got a bar that's 4 high. In the 20s, my bar would be 5 students high. No bar in the 30s, and a bar that's just 1 unit high in the 40s. So you can think of that stem and leaf plot as kind of like a bar graph. Speaking of bar graphs, the next graph that we want to look at, number 3, is a histogram, which is a bar graph. Specifically on my histogram, I have my variable along the horizontal or x-axis. So this would be x, which is my age. And I have the frequency, the number per category or class, along the vertical or y-axis. For this one, I need my distribution, or my grouped frequency distribution, that is. So I'm going to change my grouped frequency distribution into a histogram. So I need separations for each of my classes. My smallest class is 15 to 19, and I've got 1, 2, 3, 4, 5, 6. So this would be 1, 2, 3, 4, 5, 6. Perfect. Okay, perfect. So this category was 15 to 19. I'm just going to write it like this, sideways. So 15 to 19, 20 to 24, let's see, 25 to 29, 30 to 34, 35 to 39, and then 40 to 44. And then my frequency, I take the highest frequency. The highest frequency is 4. So with the highest frequency of 4, I just need 1, 2, 3, 4. And then I can go ahead and draw my bars. So 15 to 19, I've got 4. 20 to 24 is another bar at 4. 25 to 29, I had 1. In the 30s, I had nobody. And here I had 1. So that's my histogram. Finally, number 4, the last one that we're going to look at, is the frequency polygon. It's really easy to do if you're looking at your histogram, because I'm just going to put a dot on the top, in the middle, let me get my other pen, of each of those bars. And then I'm going to connect the dots. But I have to change this into its own graph. So 1 there, 1 there. I have 0 here and here, and then 1 here. So the frequency polygon just connects the dots at the top of each of those bars, and it's going to look like this. Okay, but I need to put that into its own graph. To get that into its own graph, I need the midpoints for each of these classes. So to come up with a midpoint, so I need that one because it lines up there and that lines up there. I'm going to average them. So 15 plus 19 divided by 2 will be my first midpoint. That's 34 divided by 2, which is 17. So that number right there is 17. And then I do the next one. So I'll do 20 plus 24 divided by 2. It's 44 divided by 2, which is 22. And if I keep going, I have 17, 22, 27, 32, 37, and 42. My frequencies are the same, so I just need 4 there. So frequencies, I make sure and I label it. X is age. And then I draw the same thing. So at the midpoint 17 in the middle of that class, I had 4. At the midpoint, that would be 22. At the middle of that class, I had 4. At the top of the next bar, this would be at 27, and between 25 and 29 was 1. I had 0 in the 30s, and then my last midpoint would be here at 42, and that was at 1. And then I just connect the dots to create this. Some books will start this here at 0. I'm just going to put that dotted. So you can start that at 0. It doesn't matter to me. Or you can start at the very first data point. So either one, the very first grouped point. This covers 13.1. What's not covered here is 13.2 because I have a YouTube video. So to review 13.2, which covers mean, median, and mode, and it does it for a list of data, but also for grouped data, which is what we're working on here. Look for my YouTube video, and you'll find that in this week's folder in Lessons. So look in this week's folder in Lessons in Angel for that YouTube video. You'll see it there.